Okay, hello everybody. Welcome everybody. I'm Gabriel. This is my mom, Tamar, and oh, there we go. As we get ready for this launch, I recommend buckling up for buckle up for a good ride, because we're going with the Electron. So I'm going to pull up the live stream here. Mom, if you remember to put any questions that you have in the chat. Mom, if you see any pop up.
Grandpa says he's here.
Okay. Thank you, Grandpa, for that. Let's just see. Rocket Lab. So this is a launch from Rocket Lab. We did one earlier, and as you know, Rocket Lab's a small rocket company, and they're Tamar and Jimmy both. So here from Jimmy, I'm here, Grandpa, and then there's my mom, Tamar, who's sitting here right next to me. So thank you, everybody, for joining us here. Whose birthday is it today? It's hers. Here we go. It's hers, like I just said. And so we're still waiting for Rocket Lab to start the live stream. It should be launching around 5:14. And just know that any questions that come up in the chat, I don't really want to repeat what we already said last time, which was basically just like I basically went over everything about the Electron that I know. I don't want to go over that again, but I could if you want. So it's up to you guys. Write in the chat what you want. Okay, I'll go over it. How's the weather at the launch site? One second, let's wait for that to appear over here, and then we can put it up. So I don't know. What is the weather in Wallops Island, Virginia? It's 68 degrees Fahrenheit. It's 95% humidity, 10 miles per hour rain, and 3% of the precipitation. Currently, today's Wednesday at 5 p.m. I think the live stream for Rocket Lab just started. So what I'm going to do is I'm going to share my screen. Yep, sorry. I'm going to mute the share screen right now, if I can. There we go. I'm just going to bring it up there like that. I'll move it a little bit. Okay, there we go. So, currently we're still waiting for Rocket Lab, but what I'm going to do is I'm going to mute, since something interesting is happening there. Rocket Lab was founded by Peter Beck. Yeah, the weather at the launch site is looking good. Thank you for that. Okay, so that's the launch site there. That's Wallops Island, Virginia, I think, or that's New Zealand. I'm not sure which one. Today we're launching out of, I'm not sure, I think Wallops, although it might be New Zealand. Those are some of their test fires. Let's take a look at that. So that's the Electron launching. It's a pretty small rocket. Let me just make this a little lower. That's the second stage, right after fairing separation. You can see the fairings there. Thank you guys for that. This is the 15th launch of the Electron.
Good morning and welcome to the live broadcast of Rocket Lab's 15th Electron launch. The In Focus.
Okay, so the launch is called In Focus. First, there is terminal countdown, which is countdown from 10 seconds. Then we've got liftoff, max Q, which is maximum aerodynamic pressure, staging or stage separation. And then all these happen at once. MECO, stage separation, and second stage ignition. Then we've got fairing separation, kick stage separation, and then the payload separation too. So
we have a question from the audience.
What is the payload? I know what you meant. The payload is a couple of it's a couple of small satellites, or small sats, as they're called. Small sats are satellites that are small, and so yeah, here there's iPlanet, which is 9 of the latest generation Planet SuperDove satellites, Flock 4E, medium resolution global coverage, and near daily revisit. So I think that's a photographer or photo one, and then there's another one if we go back here in the live stream. Canon 1X CSAT 2B tech demonstration, ultra high sensitivity camera for night imaging, smaller telescopes for CubeSat use. So it's another one of those CubeSats, and that's the Electron. So the payloads are actually inside those fairings that you see right over. The fairings are right over here. Sorry, but the payloads are inside of them, and that's where the payloads are stored and kept. Yeah, as we get ready for launch, just know. Oh, we've got what's the purpose of the launch? So the purpose of the launch is it's mostly it's imaging satellites, as they just said there. It's for taking picture. It's basically taking pictures of the. Well, it is taking pictures of the Earth. So that's the purpose of the launch, to launch those satellites into orbit with the with that. As still people are still streaming in. So hello everybody. We're going to take a look here. We're going to unmute it, listen in.
Ones that our customers can choose from. We have additional cleanroom facilities at our Long Beach, California headquarters for U.S. customers who want to integrate a little closer to home. And for customers launching out of Launch Complex 2 in Wallops, Virginia, we offer our brand new integration and control facility. Offering
so this is in New Zealand.
Options is just one of the ways that we've created the most flexible and tailored launch surface for small satellites. But back to today's launch, the team on console have been monitoring the health of the launch vehicle, including the payload environment in the fairing, as we progress through the count. All systems are currently green, and very soon Canon 2 and the 9 Planet SuperDoves will be on their way to orbit. Back over to you in Mission Control.
Thanks, Jane. So you're currently looking at a live view of Electron on the pad at Launch Complex 1. Electron stands 18 meters tall and weighs about 13 tons at the moment of liftoff.
Okay, so we've got a question from Howard. What will the pictures be used for? It really depends on the satellite. Some satellites will be used for just imaging, like for people to buy, and some other ones can be used to study the Earth and the landscape, and some of them to create atlases. Are the telescopes going or pointing at Earth or space or both? So I think on this launch, they're all pointing at Earth, although a couple of them might be pointing at space. So it really depends on the launch. Once again, the Hubble Space Telescope is going to be pointing at space, while the like a normal imaging satellite's pointing at Earth. No more questions as of right now. So we're T-minus 12 minutes and 15 seconds. Our dog's joining us down there. Let's take it back. Let's listen back in here. Oh, whoopsie. I X'd out of it. But sorry about that. There's our dog here. Her name is Lola. Say hi to Lola. She just burped. Good job burping, Lola. We are going. I'm gonna go back to sharing screen. Okay, Lowell's going down. Share. Let's put the audio back on.
Stations go no-go sequence is complete. We're currently T-minus 11 minutes, 20 seconds and counting. Go for the terminal count start at T-minus 10 minutes. From this time, 3-way procedure is in effect.
Okay. Who you just heard there? That's Peter Beck, who is not only the launch director but also the CEO and founder of Rocket Lab. So in 1 minute they're going to enter terminal countdown at T-minus 10 minutes. Any other questions? Is Lola as excited about the launch as you are? Well, she sees the commotion of both of us here. That makes her excited. So yeah, she likes when there's a lot of people around. So let's listen back in since we are now T-minus 10 minutes and 30 seconds. There you can see some smoke coming out of the rocket. All that means is that fueling is going normally. There's always some some steam coming out.
50 Rutherford engines. The Rutherford is also the first oxygen hydrocarbon engine to use 3D printing for all its primary components, including the thrust chamber, injector pumps, and main propellant valves.
That's right. So for the second stage, Electron uses a single.
Okay, so you just heard you obviously heard that accent. That is the accent that most English and New Zealand and other people from that area have. So it's, as you can tell, it's a company based in New Zealand. We're going back here. Let's listen back in. The Rutherford engines. Oh, by the way, we entered terminal countdown. The Rutherford engines are the engines that they use. There's 9 Rutherford engines on the first stage and 1 vacuum and Rutherford engine on the second stage. Let's listen back in.
For our family of Photon satellites employs our in-house design and manufactured Curie propulsion system. This 3D printed pressure-fed engine has a flight heritage across more than a dozen orbital missions.
Okay, so we've got a question. How many stages are on this rocket? This rocket is a 2-stage rocket. On the first stage, there are 9 Rutherford engines. On the second stage, there's 1 Rutherford engine. Sometimes they'll add a 3rd stage. I think it's called the kick stage. I think for this launch, they have the kick stage or the next stage. No more questions? We're going to listen back in. Okay, never mind. So, who owns a payload? So, I don't know. I think one's by Canon, and I don't know what the payloads are, but I know that they're small sats, so that means that they're not big companies. And yeah. So what else? Any other topics, Mom? Any other topics that you want to do?
No, I mean, this is exciting. There's 7 minutes left.
Yep, 7 minutes and 45 seconds until launch. Let's listen back in once again. Anything else?
Looks like the weather's good.
Looks like the weather's good down in New Zealand.
And how long is this going to be up in space?
So the payloads, there's a new. It depends. I think 20 years is the maximum, or they're trying to limit it to. You can't keep it in space forever, so they put it at a certain trajectory so that it doesn't hit that angle. So it doesn't stay in orbit, so they have to hit it at an angle. So let's listen back in.
Webcast shortly after kick stage separation, at around 10 minutes after liftoff. You can continue following our mission via our social media channels, where we will post confirmation of payload deployment.
Okay, so what they just said there is that payload, they won't be showing live coverage of the payload deployment, but they will have confirmation at a certain point. So we are going to take a 30-second break until we get to 6 minutes. So let's count down. Okay, we've got a question from my grandpa, or Jimmy David said, what benefits will be realized from the launch? Basically just a little bit more about knowing a little bit more about the Earth, some more people finding some images of the Earth, and learning a little bit just about space in general. Thank you for that question, Grandpa. Any more, we'll be happy to answer. Okay, I'm going to bring us back here. We are, our dog's back. Here's Lila. Her name is Lila, if you didn't know. We are 5 minutes and 20 seconds away from launch. We are getting really close. So, Lola's going crazy. We are going to take a quick little break now. Let's listen into this here.
How Rocket Lab makes truly responsive access to space a reality. The world is increasingly reliant on small satellites to power our economies, to provide scientific insights and data, and to maintain national security. The satellites providing these vital services are vulnerable, be it from natural, accidental, or deliberate actions. The ability to deploy new satellites to precise orbits in a matter of hours, not months or years, is critical to maintaining a resilient space architecture. The loss of a single satellite can have far-reaching consequences. It's why Rocket Lab developed the most responsive satellite launch system ever created. And it all comes down to resilience in numbers. Between Rocket Lab Launch Complex 1 in New Zealand and Launch Complex 2 in Virginia, USA, we can support more than 130 launch opportunities every year. It's an unprecedented level of launch availability that enables rapid replenishment of orbital assets. Resilient space is about being able to respond to evolving situations in real time. It's about having the ability to launch more than one rocket, in fact, 3 rockets from different hemispheres simultaneously, a capability unique to Rocket Lab. It's about eliminating the fragility and complexity associated with mobile launch infrastructure, and instead enabling instantaneous launch windows from paths that remain in a state of launch readiness 24/7, 365. It's about delivering responsive and affordable launch services tailored to every mission, every time. Welcome to the future of resilient space.
We can't wait to be hosting the webcast for simultaneous missions on LC1 in New Zealand and LC2 in Wallops. But for today, we're focusing on LC1.
As we approach,
Okay, so there are 2 launch sites, like they just said in the video, and it's critical to have 2 launch sites. Originally, they had 1, then they bought 1 from NASA in Wallops, which is actually not far away. It's a couple hours from Manhattan and a couple hours from Florida, so it's kind of in between. Still no questions. Any more questions? I'd be happy to answer. 2.5 minutes till launch. So we're getting ready for liftoff, max Q, staging, fairing separation, and kick stage separation. I'm not sure if we're going to do kick stage separation, although if we do, we'll probably take a big break in between because that's going to be a while after launch. So once again, thank you all for joining us. It's a big launch. Let's listen in a little bit more, learn a little bit more about Rocket Lab and the Electron. Okay, never mind.
Pretty scene there.
Yeah, it's in New Zealand. So
Looks beautiful.
yeah, it is. minute and 40 seconds. Okay, 1.5 minutes till launch. Okay, terminal countdown has started, and as you can see on the left side of your screen, you can see that red arrow going up as we get closer to liftoff. T-minus 1 minute and 15 seconds. Let's listen into mission control.
Anti-gas ring disabled.
Okay, there we just got retraction of the arm over in the middle.
Stage 1 tanks are pressed.
Okay,
And
pressurized.
stage 2 tanks are pressed as well.
Pressurization
High
successful.
flow engine purge is enabled.
40 seconds. Okay, 35, 34, 33.
Intelligence activated.
Almost there, 30 seconds. Getting closer to liftoff on that left side of your screen.
T-minus 20 seconds and counting.
20 seconds.
Should we do 10-second countdown?
Yeah, 15. Ready? 3, 2, and 1. 10,
10,
9. Oh, there you see the trajectories on the top right.
5,
5, 4,
4,
3,
3,
2,
2.
There we go. We have a liftoff of the Electron.
Wow. Oh, that's smoke.
So, actually, that smoke is from when water and fire hit, you get smoke. You can see there's no smoke coming out from behind us because there's no water to hit. Stage 1 propulsion is nominal. Good news. And it's going through the clouds, so we're missing it. That's the view.
HVB battery discharge nominal.
Okay, we're approaching max Q. Max Q is when we experienced maximum aerodynamic.
And there goes Electron for our 15th launch from Rocket Lab Launch Complex 1 in New Zealand. We're T plus 50 seconds, and Electron is approaching max Q, or maximum aerodynamic pressure, the moment during its ascent when the forces against the vehicle are at their strongest.
Okay, approaching max Q.
Maximum dynamic pressure.
Max Q.
Enter chevron 2.
So it looks like it's pretty cloudy
Enter
there
chevron 3.
because we don't really have the best view, but as we make our way up, we are getting ready for MECO stage separation and second stage ignition. Those will all happen where it says staging. We've got fairing separation and kick stage separation too.
Is that fire?
That's
AOS and Chatham Station.
because that I don't know why it does that. It like gets out as it goes higher. I think it's because
Next up will be 3 events in quick succession. We should hear the call for MECO as Electron's Rutherford engines throttle down to allow for stage separation before the engine on the second stage fires up to continue the mission to orbit.
Stage 1 burnout detect mode.
Okay, we're coming up on that 3 events happening all at once in just a couple seconds. Listen in for the call out. MECO, stage separation, and second stage ignition. Okay, we've got MECO. It's MECO, stage separation confirmed. There we go. And second stage ignition.
Separation confirmed.
For some reason,
Stage 2 ignition confirmed.
For some reason, the camera on the right is not working, but that's on their end. It's 3 minutes into flight. That's the view from mission control where everybody's watching and cheering on.
Successful MECO confirmed by mission control.
Oh, fairing
Propulsion is
separation.
continuing nominally on Electron's second stage at T plus 3 minutes into the mission. with the vehicle now traveling at several thousand kilometers an hour. Soon, the fairing halves will separate and you'll be able to watch them fall away on your screen there.
Oh, there we go. That's a fairing.
And there they go. Electron has successfully jettisoned the fairing and is continuing nominally towards orbit.
So fairings are what protects the the satellite so that they don't rip apart where max skew happened. Fairings are able to handle that stress, whereas the payloads are not. Payloads are not designed to do that, but the fairings are. That's why it works. As we get ready for kick stage separation, we're going to take a quick break here, but I'm going to leave this up on the screen for you guys. Let's listen in. We're going to take a minute or two break here, but we're going to leave this up on the screen for you guys. We'll be back for kick stage separation. Keep watching.
While we're coasting,
Coming up on battery hot swap, as I just said, where they're going to switch up the batteries. Okay, there's some good views of that Electron.
stage 2 propulsion still holding nominal.
Okay, that's some good news. Soon we're going to have kick stage separation.
Should be battery discharge holding nominal.
There you go, battery discharge holding nominal, which is the battery hop swap, although the new one is going good. We're about T plus 7 minutes and 30
We're at
seconds.
T plus 7 minutes since liftoff. In the next minute and a half or so, Electron's
Okay, so just like they said, we'll be ending the broadcast once we have confirmation of that. That should be soon, so keep tuned for that. About to come up on see you on kick stage.
You entered stage 2 burnout detect mode.
Okay. I have no clue what that means, although I think they said that the trajectory is good. It's always what you want to hear when you're launching a rocket. Good trajectory.
Guidance is in terminal, 20 seconds remaining.
Okay, let's listen in for that call out of SECO and stage separation, and also that visual confirmation. You will see it on this broadcast. So we're about to have that, so let's listen in. It's freezing up a little bit. Of course, right when we get to the good part. There we go. That's SECO.
SECO confirmed.
You can see the engine.
Thank you guys so much for watching. I'm Gabriel. That's going to end that live stream for you guys. Sorry about that. But I'm Gabriel. That's the end of our launch. Thank you for watching. Real-time updates will be from them, not from me. From Rocket Lab there, okay? That's it. Thank you guys so much. Goodbye.